want to go over some rules of factoring. I have found after teaching college algebra for many years that students who struggle in college algebra often struggle with one of the basic concepts, and that is how to factor. So I'm going to go over a very basic rule of factoring. The first rule of factoring any problem is to look and see if you can factor out a greatest common factor. You want to make sure that when you factor out the greatest common factor, that there is nothing left that any of the terms can be divided into. So if I look at the example given here, I'm looking at the numbers 2, 6, and 12. The largest number that I can divide all of those terms by is 2. I also have an x in common with each of those terms, so I'm going to factor out the greatest common factor, which is 2x. When I do that, I'm going to take each of the terms and I'm going to divide by the GCF. So you can see in my first term, the 2's are going to cancel out. When we're dividing exponents, we actually subtract. So this would be x to the 4 minus 1 is x cubed, plus 6 divided by 2 is 3. X squared divided by x to the first, we're going to subtract those exponents, and I get x. These x's are going to cancel out, and 12 divided by 2 is 6. You're going to see of all the things that I have left, x cubed, 3x, and 6, if we start off with our coefficients, 1, 3, and 6, there's nothing other than 1 that I could factor out of those or divide those by. 6 does not have an x on it, so I know that what I have left, if I've divided correctly, should be, in fact, the answer. So at every problem that you're trying to factor, you want to look for a greatest common factor. The next thing that you want to do is count your terms. The number of terms that you have is going to tell you exactly how to factor the problem. If you have 2 terms, there are 2 possibilities, squares or cubes. Now, we can factor a difference of perfect squares. A difference of perfect squares looks like the example that I've given you in 1 and 2. Each of the factors, or each of the terms, is a perfect square. Any even exponent is a perfect square, so x to the second, x to the fourth, x to the sixth, all of those would be perfect squares. And I've listed over here in this box the common perfect squares. So you should be able to recognize when you see the number 64 that it is a perfect square, and the number that I square to get 64 is 8. Look at the rules to factor a difference of perfect squares. You always start out with 2 sets of parentheses. Then the signs for factoring a difference of perfect squares is 1 positive and 1 negative. And we're going to take the square roots of each terms. In other words, the first term is x squared. What did I have to square to get x squared? X times x. So that's going to be broken up into my binomials. What did I square to get 16? 4 and 4. And you're going to see later on that the last rule of factoring is just to go back and check and make sure that you can't break it down. But as I go through, I'm just going to show you the steps of how to factor each of the different types. Then we will go into a little bit more complex ones. If we look at example number 2 up under A, y squared minus 64, we see that y squared is an even exponent, making it a perfect square. 64 is a perfect square. So if I were to factor this, it would be 2 sets of parentheses always, plus minus. What numbers do I square to get y squared? That's y times y. What number do I square to get 64? That's 8 times 8. Now, if you have 2 terms, but it is a sum of perfect squares, this is something that is prime. It cannot be factored. X squared plus 16, y squared plus 64, because of the sum of squares, these will always be prime. There is no way that I could break it up into 2 sets of parentheses, no matter what signs you use, no matter what numbers you use, to be able to multiply to get back exactly what you start. To factor a sum or difference of cubes, notice with cubes, I can factor both the sum and the difference, so plus or minus. I've written over here in the box some common perfect cubes. 1, 8, 27, 64, 125, x to the third, y to the third. So to factor the perfect cubes, what you're going to do is you're going to start off with a binomial, so a smaller parentheses, and then a trinomial, so a bigger parentheses. The signs are always for a cube SOP, same, opposite, positive. Okay, so look at the example that I've highlighted here. X cubed minus 8. I'm going to start off with my parentheses, the same sign that I have, so it's minus, same, opposite of that, positive. So you'll see the third term is always positive. Same, opposite, positive. So here's the pattern that is always true of cubes. What goes in your first binomial is the number that you have to cube, in this case to get x to the third. So we start off with that. The second part of the binomial is the number that you have to cube to get the second term. 2 to the third is 8, so that goes there. And then there's a certain pattern that continues. You square the first term. So x squared, x times x is x squared. So you square the first term. To get the middle term, you multiply these two terms together, ignoring the signs. We've already put our signs into place. 2 times x is 2x. And then you square the last term, 2 squared to get 4. Once you complete that pattern, and it may take you a little bit of practice, but once you complete that pattern, you cannot go any further. So you won't ever have to worry about breaking that down. So, look for a GCF. You count your terms. If you have 2 terms, we're going to have squares or cubes. If you have 3 terms, you have a trinomial. Now, a trinomial, there are really 2 types. They're what I call the easy trinomials and the hard trinomials. And what I mean by that is you're either going to have a trinomial who the number in front of the x squared is 1. These is what I consider to be the easy trinomials. The ones that are a little bit more challenging are the ones who actually have a number in front of it, like down here at the bottom, 4x squared. So let's start off with the easy trinomials first. When you're factoring an easy trinomial, you're always going to have 2 sets of parentheses, 2 binomials. And to determine the signs, you look at the last term. If the last term is positive, you look to the left. In my first example, you'll see that when I look to the left, that 6x is negative, so both of them are going to be negative. The reason for that, when we're multiplying it back out, you're going to get a negative multiplied by a negative. That's going to give you the positive 9. And our middle terms, we're going to add those, so negative plus negative is negative. But if you'll remember my little shortcut here, look at your third term. If it's positive, look to the left, they're both going to be that sign. If it's positive, look to the left, they're both going to be that sign. Now, if your sign is negative on the third term, such as our last example here, your signs will always be 1 plus and 1 minus. It doesn't matter if this had been x squared plus 4x minus 12, or if it's x squared minus 4x minus 12. If the third term is negative, the signs are plus minus. Think about why. I'm going to multiply these last two terms together to get a negative. The only way that I could get a negative if one is positive and one is negative. So you're going to determine your signs, and then this is how you're going to factor it. You ask yourself the famous question, what 2 numbers multiplies together to give me the last term, but adds together to give me the middle term? So looking at our last example, x squared minus 4x minus 12. What two numbers multiplies together to give me negative 12? So it's going to multiply together to give me negative 12. And it's going to add together to give me my middle term of negative 4. And we see that the correct answer is negative 6 and positive 2. So we know exactly where to put my 6 and where to put my 2. No matter where you put the plus minus, the 6 has to be negative and the 2 has to be positive. You can always check your answer by going back and doing the full method. The hard trinomials, again, which are trinomials who have numbers in front, they are a little bit tougher because you got to do a little bit more thinking and you got to know your multiplication tables. So, if we look at the harder trinomials, you're also going to write down your parentheses, and there's a couple of ways that you can do that. You can use the trial and error, which is to figure out what numbers goes in the binomials. You keep in mind you always have to be able to use the full method, get exactly what you started with. So if we look at the example, 4x squared minus 17x plus 15, you know that these two first terms have to multiply together to give you 4x squared. Well, there's only two possibilities that could give you 4x squared. 4x times x and 2x times 2x. So I'm either going to use 2x and 2x in those binomials or 4x and 1x. The last two terms are going to have to give me 15. There are only two possibilities there. I could have the factors of 15 and 1 or the factors of 5 and 3. Notice that I can use those same rules that apply to the trinomials. All right, so my last term is positive, so I look to the left. Both of my signs have to be negative in there. And so when you play around with it, you know that I have to be able to fold this back out and get exactly what I started with. So the correct answer you can see is 4x times x. That gives you 4x squared. A minus 3 times 4x gives me the negative 12x. Negative 5 times x is negative 5x. And last, negative 5 times negative 5 is positive 15. And when you add your like terms together of negative 12 and negative 5, you get negative 17. You always want to make sure that when you multiply it back out, you get exactly what you started with. The last type is if you have four terms. If you're factoring and you notice that you have four terms, you've looked for your greatest common factor, you've taken one out if you needed one, you're always going to use the grouping method. You need to really be careful when the third term of a grouping problem is negative because it will mess you up with your signs. So I've given you this example that includes one with the negatives. X squared plus 7x minus 3x squared minus 21. We're going to group the first two terms together and the last two terms. Notice that when that third term is negative, you're going to include the negative inside the parentheses, and I put a plus in front of that. Now, the reason for that is I want to be able to multiply this back out and get exactly what I started with. So a positive times a negative 3x squared is still going to give me that negative 3x squared. So again, in summary, if I'm grouping your third term is negative, you include the negative sign inside your parentheses and you put a plus sign in the middle. And then you're going to look at the first two you've grouped together. And you pull out a GCF, which in this case is x. When you factor out an x, you get x squared plus 7. In the second grouping, you're going to factor out the GCF. The GCF between negative 3x squared and negative 21 is minus 3x. So I'm going to divide both of those terms by negative 3. I'm factoring out the negative 3. But notice this, and this is going to be true of any grouping problem that's going to be able to be factored. When you look at this step, the numbers inside the binomial should be the same, x squared plus 7, x squared plus 7. When you're factoring it as a grouping problem and you end up with the same thing inside those parentheses, you're going to realize that you've probably done the problem correctly. Because what's in parentheses is actually going to be a GCF that's in common with the first two terms. So I'm going to factor the x squared plus 7 out of the first term. How do I do that? I write the GCF. I cancel out. That leaves me with an x. I'm going to factor out of the second term. I've already written my GCF of x squared plus 7. What do I have left? Minus 3. So the factoring of that grouping problem is x squared plus 7, x minus 3. The last thing that you're going to do, no matter what problem that you factor, is that you're going to look and see and make sure that your final answer cannot be factored further. You're going to see as we practice some problems in the class that sometimes we may factor something as a difference of squares. When we do that, one of the parentheses that is left may actually also be a difference of squares again. So we're going to have to break it down further and further. So always remember, first step is GCF. Second step is to count your terms. The number of terms is going to dictate how you factor that problem. And the last thing that you do is you make sure that nothing can be broken down further.